Great, okay, let's get started. Lecture 7. Things are going to start to kind of speed up a little bit now. We're going to talk about geography, health, and development today, continuing our discussion last time. I did delay the due date of the problem set again, so it's going to be due in a week. Part of that is just because I'll be covering material today and Thursday, and I just felt bad making it due. And so you guys have plenty of time to work on it. It's almost 2 weeks. In section, there's going to be discussion of stata and the relevant commands. Today's lecture is actually going to go through some of the estimation that I outlined, like the sort of equations or the conceptual frame. That's one of the questions, the sub-questions, or the parts of question 2. So I'll go through that today. Any questions on the problem set or on the timing? Hopefully this gives everybody enough time to kind of get up to speed, figure out how to get stata and stuff. Sound good? Okay. Any broader questions before we get started, or questions, concerns, anything to discuss before we jump back in? Yeah. Yeah, the syllabus is slightly different, but on the top of the problem set I put Tuesday, next Tuesday is the due date. So, yeah. And I will say a couple things, let me just say one more thing about the problem set. The data sets that are posted are made up data. They're kind of based on real data, and then I do lots of funny things to them. So, just so you know. But they look like real data sets, and they are real data sets, and sometimes they're in stata, but just so people know that. Okay. Was there another question? Yeah, go ahead. No. I want you to find certain things, and I want you to comment on those things that I want you to find. So I manipulate the data so you'll find certain things. That's totally the reason why. Okay, so we were talking about child health and income, and talked about this potential channel through education, so where we left off last time. And we talked about how there's something special potentially about child health, because child health could affect an individual's whole life course. Imagine if, compare child health problems to adult health problems. If you're sick 10% of the time as an adult, that can affect your life a lot. You'll be less productive, it may affect your ability to hold down a job. But if you're sick as a child, it could affect how many years of schooling you attain, how much you learn. If you're young enough when you're sick, it could affect brain development, it could affect how much you grow, how tall you are, all those sorts of things. So there could just be much more profound and long-lasting effects of child health problems. And those could linger even if you're healthy as an adult. If you have all these deficits as a child, it could affect your growth, your development, your schooling, for your whole life. And we talked about worms as a major global health problem, one of the most widespread infections in the world, with a range of health and nutritional consequences. And you see all the hundreds of millions of people infected with these worms. And we talked about how a lot of the countries affected are in sub-Saharan Africa, but there's actually a fair amount of infection also in Southeast Asia, parts of Latin America. And historically, there have been pretty high rates of infection in the U.S. as well. So worms are interesting, and in many ways similar to other tropical diseases in that they're infectious diseases. So the worms, as we were talking about last time, live in people's intestines. They only have a limited lifespan. People have lots of worms in their intestines because they're constantly getting reinfected with worms. And you get reinfected by coming into contact with infected fecal matter. So it's basically fecal matter that has worm eggs in it. That's the typical way people become infected. So in settings where there isn't very good sanitation, in other words, people don't have toilets or even latrines, and where there isn't very good hygiene, so people say aren't washing their hands adequately before eating or before coming into contact with others, in those sorts of settings, you would tend to have a lot of transmission of worm eggs. And this is a major problem in many poor countries where coverage with toilets and latrines is often limited, where people often don't have access to as much water as they would like to be able to clean their hands, or if they do have access to water, they may or may not have the cultural norm of regularly washing their hands before eating, say. So there's a range of different issues or problems, health, sanitation, hygiene, and water problems that can all contribute to having worm infections. And what's really interesting, though, about dealing with worm infections is because of their infectious nature, treating one person could benefit others. In other words, treatment for worms generates an externality. If I'm infected and then I become treated, so I can no longer pass worm infections on to my siblings, to my parents, to my neighbors, their reinfection rate is going to fall. And reinfection is really critical here. The worms only have a lifespan of roughly 1 to 2 years on average. So for instance, if my neighbors aren't getting reinfected as often for a year or so, a lot of worms in their bodies are going to die off. And they're going to have fewer worms in their intestines. They're going to be healthier. So the basic idea is the more worms that are in your intestines, the greater the disease burden. If you have tons of worms in your intestine, more of these worms are eating your food, affecting your absorption of nutrients in your intestines. If more of them are boring into the intestinal walls, you're going to have more bleeding, more blood in stool, and more anemia. But it's really increasing in the number of worms in your intestines. You get anything from one worm in your intestine up to hundreds of worms in your intestines. So reducing that reinfection rate becomes very important. And economists are very interested in externalities because the optimal sorts of policies that we advocate as economists may differ depending on whether there are externalities to a certain behavior or not. If there's no externalities in the very kind of standard libertarian view of economic theory, individuals should weigh the costs and benefits of different actions and sort of take the action that benefits them most. Once there are externalities, we're not in that libertarian world anymore. By getting treated, I'm not just benefiting myself, I may be benefiting all my neighbors, and I may not be adequately taking that into account when I make my own decisions. So what's good for society may no longer be what's good for me. And that's a setting where subsidizing treatment might be optimal. Okay, so this is an idea we're going to come back to. We're going to talk about externalities, we're going to talk about estimating externalities, we're going to go through what the econometrics would look like when you have externalities, and also what the externalities look like in the data in Kenya. So that's going to be one of the sub-themes over the next few lectures. Beyond the sort of direct effects of treating people for worms is going to be the social benefit to treating some people. Now the same sorts of mechanics or dynamics would occur with other diseases as well. If people, we're going to talk about HIV/AIDS next. One fewer person who's infected with HIV/AIDS means potentially less HIV gets passed on to others. So there's a social benefit to, say, reducing infection rates. So let's keep that externality issue in mind as we go through this. I've already mentioned the lifespan issue. So the bad news about worms is what I said before. They're everywhere. They're widespread. They have all these health and nutritional consequences. They're spread throughout the community. They're infected fecal matter in these poor settings where people don't have hygiene and sanitation. That's the bad news. The good news is at least there are cheap and effective treatments. Albendazole and praziquantel are the names of drugs. Albendazole to treat the soil-transmitted helminth, hookworm, roundworm, and whipworm. Praziquantel to treat schistosomiasis, which is this waterborne helminth where the intermediate host is a snail. I think I mentioned that in the last lecture. So you don't need to treat that often, only every 6 months to a year. The drugs cost less than $1 per person per year, including delivery costs, transporting them to the site if you have mass treatment. And the side effects doctors consider minimal. Now, there are some side effects. If you have 100 worms in your intestine, the drugs are killing off all those worms. When the drugs are working that night, you've taken the drugs during the day, you're going to have a stomachache. and you're going to pass lots of worms out with your fecal matter, which is disgusting. Some people vomit up the worms if they have a sufficient worm burden. So again, doctors are like, oh, these are transient minor side effects. There's no major consequences. But if you have a lot of worms for like 12 hours, it's going to be a little bit unpleasant. And in our data from Kenya, about 12 or 13% of kids report having some of these side effects: stomach ache, diarrhea. In a very small number of cases is they're vomiting. But the program we study is a school-based deworming program. So all the kids line up and they take deworming drugs. So you can imagine if even one kid out of 300 vomits after taking the drugs and is vomiting up worms, it's pretty salient for the other kids. Yeah. No, it kills those worms. It kills those worms, but there could still be worm eggs in the fecal matter around. So killing the worms in your body is going to reduce reinfection caused by those particular worms. But if there's already worm larvae around, or there's other sources of worms in the community, reinfection will eventually continue. So there's different ways to treat the problem. And solving all the hygiene, sanitation, and water problems in the community will really reduce the worm burden. Treating everybody with these drugs will also reduce the worm burden. The sort of logistics of having people take 1 pill a year or 2 pills a year, at least in the short run, is easier than building complete hygiene, sanitation, infrastructure. In the long run, we want to build that infrastructure. Of course, as countries become richer, they do build all that infrastructure. So you could think of these as substitutes for each other. But achieving full sanitation coverage isn't something you can do as quickly as mass distributing deworming drugs. So at least in the interim, these can be effective. That's the way we think about it. Any other questions on the health issue? Given how cheap the drugs are, even now they're 30 cents per person per year and whatnot, it's pretty hard to beat the cost benefit on this relative to anything else. I'll mention probably next lecture that as part of this program, in addition to giving out drugs, the NGO we work with did a moderately serious health education campaign about hygiene, avoiding infected fresh water to avoid schistosomiasis, trying to wear sandals or flip-flops to avoid stepping on hookworm eggs. That's the most common way people get hookworm infections, etc. And then we measured behaviors afterwards and found that in the first couple of years of the program, there was no measurable behavioral change. So the other issue here is in some ways, mass treatment is faster than behavioral change. Behavior change in health is notoriously difficult. So if you have to factor in not just building the latrines, but getting everybody to use them, or not just providing the water source, but getting everybody to wash their hands regularly before eating, etc., then those costs could multiply. I don't know if people have actually done the math on that. I think that one could do. But I think when you think about the infrastructure investments, you have to also think of the time it would take to achieve the behavioral change, and that would sort of affect the cost-benefit calculation. Yeah. There's starting to be reports of drug resistance recently. At the time we did the study, no. The drugs have been around for a few decades. So these aren't drugs where there's been like very quick resistance, like some antimalarials have developed resistance in a short amount of time, but there's starting to be some reports of resistance now. And then there would be needs for further drugs, et cetera. But it's not considered a kind of major concern yet with these drugs. Okay, what's the impact of worm infections on education? We're going to have our first clicker question on this. And you've got the question there, which is just when you think about all these nutritional health consequences we just talked about, and we think about primary schooling, which dimension of education do you think is going to be most affected? Now, for those of you who have done the reading, you kind of know what the answer is. That's fine. Go ahead. Don't try to get back in the mindset you were in a week ago. Just answer what you know now. That's fine. But I want to get people's views on this, because maybe not all of you have done all the readings or done them very carefully. So the options are academic test score, school attendance, primary school graduation, or all three roughly equally, whatever that means. Okay, 5 more seconds. Okay, so people do the reading. I like this. I'm proud of you guys. That's good. So yeah, school attendance. That's where we see most of the action. We'll get to that. We collected data on all these things, and we put time into collecting test score data. But we, as we'll talk about in the data, put a particularly large amount of time into measuring school attendance and school enrollment, precisely because we thought that would be a very obvious margin for adjustment, or where you'd see the impact if people were sick. If you're sick, you can't go to school. But we also collected test score data. But it was certainly, our view wouldn't have been quite this skewed in terms of our prior view on where the impact would be. But we had a lot of interest in school participation. Okay, so what's the impact of worm infections on education? The pattern you see in the data, this is just getting back to this conceptual framework, which we're going to be building up throughout the course of the semester when we think about treatment effects. We do find that those with worse infections tend to have worse academic performance or educational performance along a variety of dimensions. So, if we kind of slightly tweak the setup we had before and say, okay, let's look at the correlation between health and education rather than say health and income. They're clearly positively correlated in data you would collect in rural African schools. You would definitely find that kids who are healthier tend to do better in school and vice versa. There is this correlation. And the question that we're most interested in, the question, the hypothesis we're interested in answering is really one: do health investments like these deworming investments improve education? So we're hoping that the study will shed light on that. But there is a concern when we see correlations like this that there is some third factor, which we talked about before, the omitted variable or confounding. And can people just, we mentioned some of these before. What are just some obvious omitted variables or confounders that we'd be concerned about? If we, imagine we had test score data or we had school attendance data and we had some measure of health, we find they're correlated. Why might they be correlated even if theory one here is not true? Okay, so there's a range of maybe parental education, socioeconomic status, parental attitudes, maybe certain parents are providing a home environment where kids' sorts of educational needs are being met as well as their health and nutritional needs, and that might correlate with family income very strongly. So there could just be something about poor kids having outcomes that are worse than rich kids in a variety of dimensions. And if we don't have really good data on those socioeconomic controls or income, we might, erroneously conclude there's a causal effect. There's another hand up in the back to do another same kind of idea. If people think of any other reasons why these might be correlated? Yeah. Yes, that's really good. So instead of thinking of the home environment, we might think of what we would call supply side issues, which is there just may be more supply of schools and clinics in a certain area, and the people in those areas have access to both. So the effective cost of accessing healthcare or getting education might differ for different people. And might be much lower in more densely populated areas. Okay. What the kind of third set of questions, Lauren? I see. So it's a bit of a different supply side issue, or a different interpretation or spin on the supply side issue that you said. Okay. Yeah. Yeah, so this is a very good point. So independent of access and independent of family background, there may be aspects of a child's personality, their own characteristics, which make them, follow the rules or not follow the rules. And you said they're naughty. I know all about naughty children, as you've seen in the picture. And if children are naughty, they may not wash their hands enough because they don't want to do what their parents tell them, and they don't do their homework, and it's just the kid's personality or the kid's ability level or something about their characteristics, right? So this is great because people talk about child level characteristics, and maybe hard to measure. Most surveys don't ask the child, how naughty are you? That's not in our data. If you have a census form, last I checked in 2010, they didn't ask me which of my children was naughtiest. They might have. I would have an answer. It's my daughter, by the way, if you could tell by the pictures. Oh my God. But we don't have that data. And maybe that's absolutely critical. The child's personality is going to matter. Or something about the parent's attitude towards their kid's education could matter. Or something about the community could matter. So in all these different scales, there are potentially hard to measure characteristics that could affect both health and education that you guys came up with within 1 minute. So thinking about all these limited variables at different scales that are hard to measure really is part of the reason why experimental designs, like the ones we're going to talk about, have taken off as research designs in empirical economics and in empirical social science over the last 15 years. There's a concern that no matter how good our data is, we're not going to capture all these dimensions of individuals, households, and communities. And that's why we need to go to different approaches. Okay, so let's think about what a regression would look like here. Imagine we're interested in regressing some outcome y, which here would be an educational outcome. So let's just think of this as school attendance. Or it could be a test score, whichever educational outcome you want. And we're regressing that on W, which is the worm load, in other words, the number of worms that are in a kid's intestine, which you can actually measure in data if you collect stool samples. So again, whenever we talk about worms, everybody's making faces. This guy here's making faces, I'm making faces. Sorry, but that's how you measure the intensity of worm infections. So let's say we have a measure of that. And then there's some other characteristic x that also is going to determine the kid's schooling outcomes. And the x's we're thinking about, let's think of it as just one variable here, but in reality x is a vector, meaning it's many different variables of individual characteristics, household characteristics, community characteristics. It's everything beyond worm infections that can affect schooling. So again, you can think of probably 50 factors in about a minute, individual, household, and community that could affect schooling. Let's think of it as one variable now just for simplicity. Okay? So the educational outcome, school attendance, actually for simplicity, let's just say you have worms or you don't, just make an indicator variable for simplicity, and the child characteristic is household poverty. For simplicity, because that's everybody's immediate omitted variable or immediate reaction. And again, we can think about it as being a 0 or 1, or it could be a continuous variable. What we want to do in regression is estimate these parameters. We want to estimate A, B, and D. We care about B because we want to understand the effect of worms on outcomes. Imagine we're a government trying to figure out whether we're going to expand de-worming programs. We have to understand what the impact of worms are on kids' outcomes. So we need to know B. Throughout this whole exercise today, our goal is to estimate B, and we're going to talk about all the challenges to estimating B. Estimating D is pretty good too because we want to understand how these other factors affect education. But for now, we're focused on health. We have to sort of solve problems, one thing at a time. And E here is going to be the standard white noise disturbance term. So it's just going to be independent of, it's going to be mean zero and conditionally independent. It's basically an IID error term, the standard IID white noise error term. The subscript I here denotes a person. Now, it can also denote a school. It can denote whatever unit we have data on. And if you guys look at the data set in the problem set, for the Econ 174 folks, there's a school level data set that I posted. And for the Econ 274 folks, there's a school level and individual level data set. So you could think of I as being whatever the unit of observation is. Individual, school, community, whatever we have data on. Doesn't matter conceptually. Now in practice, there may be differences to estimating things at the school level or the individual level. We'll talk about that a little bit. Let me pause for a second. Everybody should be familiar with this kind of notation or this kind of regression equation. If you're not, then you have some catching up to do. But I think hopefully people are familiar. Any questions? Yeah. Treatment here is not a variable. So here it's worm infection. Later on in lecture day, I'm going to switch to worm infection. So the reason I'm going to switch to treatment. The reason I'm putting worm infection up here so far is I've been conceptualizing this as a correlation between a health measure and an education measure. So for continuity, I'm going to kind of start looking at a health measure. Later we'll switch to a treatment variable. Now the issues are very similar, but thanks for noticing that. I'll point out in 25 minutes when I make the switch to focusing on T, the treatment dummy, rather than W there. Yeah. Exactly. Yeah. So this is a little different than a treatment effect. This is an effect of bad health on education. Now if you were starting in a setting where everybody were infected and the treatment worked for everybody, then W would just equal 1 minus T, or T would equal 1 minus W. So it would be the same. And that's the kind of switch we'll make in half an hour. Thanks for pointing that out. That's important. Really, throughout the chart, we're going to focus on treatment effects and treatment dummies, but I'm kind of starting here, and then we'll go there. Any other questions? Okay, so this is, as everybody pointed out, and I highlighted because I want to emphasize this distinction. This is the indicator for having worms. This is like the indicator for being sick, basically. Okay, what are our expectations in a statistical sense? What is the sort of average outcome in different cases, where we think of the expectations operators, you've learned it in your statistics class or probability class, probability theory. And let's imagine different cases. So for simplicity here, we're going to have x take on values of 0 and 1 also. So we're going to have a very simple case. There really can be 4 different cases. You can have W equals 0 and x equals 0. That means you have no worms, but you're not poor. Let's let x equal being poor. There's going to be W equals 0 and x equals 1, so you don't have worms, but you're poor. And then W equals 1, x equals 0, W equals 1, x equals 1. Just to illustrate the algebra, all of this generalizes to a more continuous case. So what is the expectation? Okay, it's A, if we take the expectation of constant, of course it's just a constant, plus B times the expectation of W conditional on W equals 1. So what's the expectation of W if W equals 1? Just 1. The expectation of x conditional on x being equal to 1. And then the expectation of E conditional on those x and W conditions. That's just 0, right? Just by the definition of the error term here. So